Our next topic is graphing the sine and cosine functions, and yes, we get to graph with transformations as well. We're going to start off by filling out a t-chart, and notice the only values we have for our angle of rotation, which is our x value, are the ones on each axis. So if we think about setting up our unit circle, those ordered pairs start off at 1, 0, and then rotate up to 0, 1, over to negative 1, 0, and down to 0, negative 1. Sine is our y value, so at negative 2 pi, a full rotation in the clockwise direction, our sine is 0. Negative 3 pi over 2, our sine would be up at 1. Negative pi, we're back to 0. And negative pi over 2, we're down to negative 1. At 0, we're still at 0. Up to pi over 2 at 1. Over to pi, back to 0. Down to 3 pi over 2, we're at negative 1. And a full rotation, we're back to 0. The reason these are the only values we need are because these occur when sine is at its maximum, which is 1, the minimum, which is negative 1, and then a point halfway between those, or 0. So those other sine values that we've memorized will be on the graph, but we can still get the curve of our sine function with just these three sine values. Setting up my graph, we have pi over 2, pi, 3 pi over 2, and 2 pi. And on the left, we've got the negatives. As I mentioned, our minimum is negative 1, and our maximum is 1. Plotting those points, negative 2 pi is 0, negative 3 pi over 2 up at 1, back to 0, down to negative 1, back to 0, up to positive 1, 0, down to negative 1, back to 0. Our sine function looks like a wave. Notice at those maximum and minimums, they are curves, not sharp points. So think more like a parabola versus the absolute value function when you're graphing your sine curve. Down at the bottom here, we've got some information to fill out about our sine function. First of all, domain. Think about what you put into your sine function is an angle. You can rotate to any angle, positive, negative, or 0. So our domain is all real numbers. Our range is the output. Looking at our graph, our curve bounces between negative 1 and 1. In set notation, they are both included. We do get those values out of our sine function. In inequality notation, we would do negative 1 less than or equal to y less than or equal to 1. I will accept both notations to express your answer. The period is how long it takes for one full rotation, or for the sine function to get back to where it started and begin again. When you look at this curve, here we're getting back to 0, but it's not the full rotation because we haven't hit any of those negative sine values. Once we do a complete rotation of the unit circle, 2 pi, we get back to where we started and we start over again. So the period of the sine function is 2 pi. The amplitude is how high the wave is, starting at its middle. Another way to think about it is how tall is the wave from the bottom to the top, and then you divide it by 2. Here we've got an amplitude of 1, or you can think about the fact that we went from negative 1 all the way up to 1, which is 2 units, but then you have to cut that in half to get your amplitude. Next, we're going to take a look at the cosine function with those same values. Cosine is x-coordinate. Over here we have 1, 0. Up at 0, 1, over to negative 1, 0, and down to 0, negative 1. So filling in this chart, a negative 2 pi rotation would be the cosine value, the x value is 1. Negative 3 pi over 2, we're up at 0. Negative pi, we're over to negative 1. Negative pi over 2, we are over 0. At 0, we have a cosine value of 1. Up at pi over 2, we have 0. Over to pi, negative 1, down to 3 pi over 2 is 0, and back around to 2 pi, we are at 1 again. Our cosine graph looks very similar to our sine graph, except it's shifted because we're not starting at 0 like we did for our sine function. We're starting at 1. We have those same minimum and maximum values for the cosine function as well. This time cosine starts up at 1 at 0, comes back to 0, down to -1, back to 0, back up to 1. Again, nice smooth curves. And then on the opposite side, down to 0, down to -1, back up to 0, back up to +1, and nice smooth rounded curves at those turning points. Domain, we can still take the cosine of any angle of rotation. Range, we still have those same maximum and minimum values that the sine function does. Period, again, when you look at one wave of this function, we're starting at 1, going all the way down to -1, and then coming back up to 1. It takes a full 2 pi units to do that. And our amplitude, the wave is still bouncing between -1 and 1, so our amplitude is 1. Here is a summary of the sine and the cosine functions, as well as their transformations. If you're multiplying out front of the function, that will give you a new amplitude. The amplitude of sine and cosine is 1, so when you multiply that, that's a vertical stretch, so it changes your amplitude. If you multiply your x value by something, that is a horizontal stretch. So what that does is it changes the period of the function, which is how long it takes the function to complete a full rotation. So it's horizontally compressing it or stretching it out. D, adding that onto the end, would be a vertical shift. And of course, if your A is negative, that would be a vertical reflection. Next, we're going to talk about symmetry. So let's jump back to the graph of the sine function and take a look at its symmetry. This one you could rotate. If you look at that blue wave and you rotated it around the origin, you would end up on top of that green wave. So the sine function has origin or rotational symmetry. Taking a look at our cosine function next for its symmetry, notice it can be reflected across the y-axis. So this has y-axis or reflectional symmetry. We talked about the domain for both functions is all real numbers. That doesn't change under a transformation. The range depends on any vertical shifts as well as the amplitude change. So your y will bounce between the maximum and the minimum. There is an error here, put underlines on both of those. It does include the minimum as well as the maximum. When you're graphing the sine and the cosine functions, you want to look for these 5 key points. What we did on those parent functions that we just graphed: maximum, minimum, and the intercepts, where the graph crosses the x-axis, which will occur halfway between your maximum and your minimum. In the next video, we'll take a look at putting all of this information together and getting some transformations graphed for you.